Hi everyone! Today I'm going to show you the Programming 5 homework assignment for EGR200. In this assignment, I'm showing you step by step how to download data from the internet and pull it into Matlab to be able to create plots for your Unit 2 project. In this, you'll see a lot of different options that are available for plots, and really it's up to you to decide what kind of data you want to look at. So any data that you can download as a CSV file is probably a good possible project. It could be weather data, it could be farm data, it could be information about something that you're interested in, like music. So I'm going to start with this Spotify charts, and you can see on here that you can get chart data for different countries. You can do daily or weekly sums of the data, and you can choose what week or what date you want the information for. As soon as you've found what information you want to download, you simply click download to CSV. And I did this for 5 different countries last week. So I did this on April 16th. And I downloaded data for Australia, Great Britain, New Zealand, US, and South Africa. So they're all English-speaking countries, and I wanted to look at how the streaming rates differed in those different areas. So what I'm going to show you is a tool that is built into Matlab that's really helpful for a project like this. And honestly, it's one of the nicest things about working in Matlab. If I go to the Home tab, I see that there's an option to import data. So I could try lots of different code and use the import function to figure out the absolute best settings for bringing in this data in the format that Spotify has made. But since I don't really know what it looks like, I don't know how many columns it has, I don't know where the column headers are stored, I can use this wizard to be able to select the data that I'm interested in and figure out the formatting options. So I click on the Australia file, I click import data, and it loads, and it gives me a lot of different choices. So I can pick different commas, different delimiters. So I could look at what it would look like as a tab delimited. And you see it all melds together because this is a CSV file. It's comma separated variables. And I can see that when I choose comma, I get all of the information in each column nicely organized into my table. I also can see in the data that the second row is where all of the variable names are stored. So variable names row, I'm going to change to be row number 2. And now my variable names have updated to be position, track name, artist, streams, and URL. I'd like to look at the position on the chart, the track name, the artist, the streams, but I don't really want to keep the website. That's something I won't be able to put on a graph. So I'm going to change the range of data that I read in. Instead of being from A3 to E202, I'm going to read in to D202. So now I'm reading in those first 4 columns of data for all of the rows in this CSV file. Once I have the information that I want and it's coming in the output format that I want, I can import the selection. I could simply click import data. So this would be the easiest option for your project. But I could also make a function. So if I generate a function, I'm now going to have all of these formatting settings saved as code that I can apply to the other files. So that's the option that I chose. When I generated the function, it automatically put into code all of the settings that I chose in the graphical interface. And it has 2 inputs that I need to put, 2 parameters that go into this function, file name and data lines. I renamed my function. Instead of being named after the file, Regional AU Daily Latest, I changed it to be called Read Spotify. And now I have a function that I can call on all of the other files that are in this folder. So I'm going to clear my workspace because although I've read it in with the import data function, I want to read it in with the function. And I'll show you how this works. So Regional AU Daily Latest, read Spotify, that file. And the second parameter is the number of row to start reading the data on. So the data starts on row 3. So that's why I put 3 for all of these different CSV files. Once I have read the data in, I can check the size of the data just to make sure that they're all being read in correctly. If I apply the function from the first file, I want to make sure that it works on all the other files. And you may only have one file, so you may not need to do this, but if you have multiple files, making a function is a really good approach. Now I'm going to look at what data comes from each country by adding an extra column. So the AU column, GB, NZ, is getting added to every single one of the 200 rows in the table. And so now I have 5 new tables. And one thing I discovered when I tried to put these 5 tables together is that the US data had a little bit of a formatting error. The artist column came across as a categorical column instead of a string column. So these 2 lines of code just fix that column, which enables me to use vertcat, that function, to put all of these different tables into a single table. Once all my data was in one place, I looked at the data to try to come up with 3 different plots that I thought would tell a story about what information is stored in these files. So the first plot example that I came up with was looking at the top song. So all 5 of these countries on April 16th had the same top song by Drake. And we were able to look at what the popularity of that song was by not streams, because they're really different sized countries. It's hard to compare total number of streams. So it's the number of streams for the song divided by the total number of streams for the top 200 songs in that country. It's a way of just normalizing the value. So I did this with a for loop. I set a value of % top streams so that it had a vector that was defined that was 5 long, and then ran through the for loop to be able to come up with what was the sum for each individual country. And then the % was just equal to the number of streams for the song divided by the total number of streams for the country. Next, I was able to make a plot of that and look at each country on a bar plot. For the second example, I wanted to look at popularity not by song, but by artist. So I did this by adding up the streams for every artist for all 5 countries. And what I found was that Dua Lipa doesn't have a top song. She's not in the top 1 or 2 songs, but she had multiple songs that were in the top 200. And so that pushed her total count in terms of millions of streams to be almost as high as Drake. So I was able to plot those 2 artists against each other on a bar plot. And then for the last example, I made a vector that looked at the number of downloads and the number of streams for every individual position on the top 10. So the top song, the second top song, the third top song, I was able to sort of see like how steep of a curve is it? Is the second song almost as popular as the first song, or are they a really steep curve and that top song is a lot more popular? And so those are my 3 plots. I'm going to run the program so you can see the results of it. And you can see that each of these plots show a different piece of information from the files. So Australia, UK, New Zealand, US, and South Africa, it's about the same percentage, about 2% for the top song of all of the streams for the top 200 songs. In figure 2, you can see that these 2 artists had approximately the same number of total streams from all 5 countries on April 16th, around 3 million. And then on the third chart, you can see that the US has a much steeper curve and a much higher difference between the first song and the 10th song than a country like Australia or New Zealand. In your project, you can be creative. You can pick whatever data set you're interested in and whatever types of plots you think best represent it. For this assignment, all you need to do is get the code working on your computer with these 5 files and then change this plot, figure 2, so that it's 2 different artists. So if you look at the code, you can see the spots where I've specified which artist to look for, change those, and also change the graph to labels so that they're labeled correctly, and then submit your final picture as a PNG file. And just to see how to do that, I will rerun this. If you have a plot that you want to save as PNG, you can do it in a couple different ways. The easiest is probably just to save as, and all of these different options pop up. So one of the options is portable network graphics file, PNG, and you can save that and upload that file to Canvas. Let me know if you have any questions, and I hope this helps you get started with your Unit 2 projects.